So, good evening, all the participants. Today's speaker, Dr. Ashish Deoghare, sir, on behalf of Maharishi Karve Stri Shikshan Sanstha's Cummins College of Engineering for Women, I welcome all the participants and the today's speaker for a fifth day in online 6-day online faculty development program on 21st century materials, advancement in material science and technology. We all know that this program is sponsored by AICTE ATAL AICTE Training and Learning Academy, that is ATAL, and we are doing this program in association with ASM International Pune chapter, that is American Society for Materials. We are doing with in association with them. Now let me take a privilege to introduce Dr. Deoghare sir. Dr. Deoghare sir has completed PhD from VNIT. His research interest is bioscience, synthesis of biomaterials, mechanism of machine development. He has a 24 years of total teaching experience, more than 50 publications he has published in reputed journal and conferences. Eight students have completed the PhD under him, and 4 is under the process. He got 8 patents, and all are granted, and most of the patents are related to the biomaterials and composites. That is, composites he has developed the composites using biomaterials, biodegradable materials, and bio-related materials. And more than 25 projects he has supervised for MTech and BTech. He got various fundings from Ministry of Education, Department of Science, Technology, DST as well. More than 4 crore of funding till now he received. Currently, he is associate professor in Mechanical Engineering Department of National Institute of Technology, Silchar, Assam. So I welcome you, sir. Now I request you please proceed with your topic.
So thanks the Cummins College of Engineering management for giving me an opportunity to discuss my little bit work. The work it is actually done by my research scholar, and that only I am presenting. Without the scholar, it is not possible for a faculty member to do everything. So just I am sharing the few things, and later on the thing it will be taken by my research scholar, and he will also discuss in depth the current work which he has doing, and what in the past that we have carried out. Okay, so I hope my slides are visible.
Yes, sir, your slides are visible.
Okay. So the today's topics it is related to the development and characterization of the composite materials for different applications. And here directly I will jump to the patented work that we are done during this research work. So this particular patent, if you look, that is the development of the composite bones scaffold using the hydroxyapatite derived from the caprine bones bio-waste materials and using the composite that is the binder. PLG is a binder. So this is a which we can say that the project or the patent which we have obtained. Particularly in this, as we know, the peoples are consuming the different kinds of the meat products or the meats, particularly chicken, then the goat bone it is there, or goats, and the bones are discarded as a waste into the garbage. So we thought that why not that particular bones can be used for preparation of a biocomposite materials, and which can be a substitute to the bone materials. So for that purpose, this particular patent it is granted. Obviously, in more details, the things it will be explored in the later on stage. The second patent which we have also got, it is related to the fish bone, as well as we can call it as the from the fish, which normally the fish bones are thrown away, as well as the scaffold, which as well as the fish scale which are there. That is also a enriched source of the calcium and the potassium, and these particular two basic components can be basically used for preparation of the bone substitute. So owing to that theme, here in the northeast region, particularly the fish are a daily, you can call it as a food for the local peoples, and they are consuming it. And based on that, normally the fish scales and the fish bones are thrown away. So that is also again a from the waste to wealth, that concept we have adopted it here for development of the you can call it as the composite materials, which is again a substitute for the bone. Not only bone, that we will also discuss a few applications, what are the things which can be done by using this particular patented technology, that also we can discuss. This particular, if you see these two particular patents, they are basically using the natural sources. That's why deliberately I have kept this particular slide to make you aware that when we take anything from the nature, then we must require to acquire the NBA approval. So this NBA approvals is not the National Board of Accreditation. So basically this particular type of approvals, it is a National Biodiversity Act, it is there to grant any kind of a patents and which you are using the natural sources, to that this particular whatever the idea which we are presenting and the claims which we are using, the government of India as well as in the universe also, that means in the world also, this particular act it is followed, where they are saying that we should not disturb the biodiversity. That means without the exploitation of the nature, if you are doing it is well and good, then they will grant it, otherwise they will stop. That means whether the technology it is although a patented or it is a very good kind of a technology, still without the NBA approvals we cannot able to have a patent, or we cannot got the patent. So that for that purpose only this particular slide I am focusing it. That means those who are interested to use the natural resources for their products, particularly which is having based upon the animals or the plants, so to them this particular you can call it as the affiliation, this particular certifications is, it is a very very essential one. The third patent which we have acquired, it is related to the development of the composite material for from the degradable cashew nut shell. As all we know that the cashew nut we are consuming it, but the shells are discarded, but this shell it is also having a unique property. Particularly this property of anacardic acid it is there. That means it is some kind of a poisons which this particular shell is having, and that's why whenever the peoples who are plugging the cashew nut fruits, they are required to be very very careful. If suppose the drops of the cashew nut or that oil, if it is spill on their hands, then it can burn. Being it is a having a you can call it as a poisonous kind of a property it is having, or toxic property it is having, this particular composite which we are claiming that develop, it is been a substitute for the repellent of the termites, cockroaches, and other things. So for that purpose, this particular patent we are that means asked for the government of India, and they have also granted this particular patent. So please note again, for this also we have to pass this National Biodiversity Act, because we are using the cashew nut shell as a main ingredient, and we are not harming it, otherwise it is also a waste. And based upon that, they are giving us a or they are granting the patents. Then again, the next patent which we are having, it is related to the this is also a very interesting kind of a patent. That means development of a composite materials for efficient electromagnetic interference, that is called as the EMI shielding. First of all, I will let us discuss this particular. That is what is mean by the electromagnetic shielding and its interference. So if suppose somebody give me a ring, then obviously on my mobile, the with some incident or frequency, that mobile it will be working or it will be having a ring, and this particular incidence frequency which is there, so that will be uh, get there, that may get interfered with the other electronic devices. Now we are marching towards the 6G or 5G kind of the frequency band or the frequency, and to such a high incident frequency, we may require to have a compatible kind of a materials which cannot have a hindrance with the nearby uh, electronic equipments. That means particularly we may observe it when we are holding a mic, and nearby the mic, if suppose the mobile it is there and it is having a ring, then it will have a hindrance or it will have a interference. This particular type of the, and obviously nowadays we are required to go ahead with the high end frequencies that we require to have. Recently we may notice that in the news also it is shared that uh, as soon as the this particular type of the 6G technology it is adopted in the America, so then they are having a some kind of a disturbance in their area, that is aviation sector, and they have then again rescheduled to its back to the 4G technology, and then gradually they are now shifting towards the or trying to have a that means controlling the interference because of the high end frequency. This particular material which we have developed, it can be best suitable for the radar sensing. That means where we require to have a frequency which is incident on the material which is very high, and we believe that or we think that it should not have any kind of interference with the another one, or the whatever the information which is coming, it should not be passed or it should not be leaked to the outside. So for that a compatible material it is required, and for this for this purpose we are develop a material or a composite materials, and that too in the base material for it is a graphene materials, and these graphene and reduced graphene oxides which we are used it, and this particular graphene materials we are trying to extract it from again the waste sources. It can be used it from the garden waste or the garden plants which we can use it, and from that we can able to prepare the this particular type of the composite materials, and for that purpose this particular patent or this technology, it is also received a patent from the government of India. So based upon this again I will show you some kind of a patents particularly in this particular so these are the patents which are basically related to the composite materials. But in today's discussions I will just focus it on the biomaterials and its related uses and how we are doing its synthesis. As all we know that the bioceramic is what that we are having a that means in our day-to-day life we came across this particular type of material, bioceramic materials, the ceramic material that are biocompatible and basically which is used for the medical and the dental implants. So they are the bioceramic one. So there are certain properties which this bioceramic it has to pass. That means their chemical properties and the physical properties that has to be compatible with the uh, integrated or the implant where we are required to use it. So the basic biomaterial which we have prepared in most of the our technology, it is related to the hydroxyapatite. So this is you can call it as a base materials or a bio ceramic materials, and it is the mostly uh, in a layman's language, it is a uh, two types of the compositions which are there, that is the calcium and the phosphate it is there. So these are the two major components which are uh, included in this particular hydroxyapatite, and this particular composition, it is again best suitable for the bone morphology or bone substitutes kind of the things, and that's why here we have considered the base material as a hydroxyapatite one. So uh, obviously these are the it is most compatible with the, you can call it as the bone materials and the Ca by P ratio. It is also meeting to the natural bones. So, and that's why the hydroxyapatite it is we have emphasized it more. So based upon this, again, we have obtained the patent which I have discussed it. That is the for the caprine and the galine bones. Even he in the northeast region. So the no doubt the cow it is a preyed all over India, but here it is also consumed it. So that is referred it as the bovine bone. So that also otherwise the bones it is thrown outside, so that can be also again be useful for developing the substitute to the natural bones which we require to use it, particularly in case of the uh, uh, when we are facing any kind of that means injury or the bone damage or because of the accidents and other things. So basically the skeleton which we know that it is a constituents of the bones and the that means the ligaments, the bones provides in a layman language I am just speaking. So the bone it is giving us the strength as well. That means you can call it as a structure it is given by the bones, and the strength it is given by the ligaments. So biocomposite materials it is having the two phase kind of the things, that is the protein, that is the collagen, and the calcium phosphate, that is the Ca by Ca and P, that is the calcium phosphate. So these are the you can call it as the requirement of the bones, and the bone it is basically consist of the two you can call it as a part, that is refer it as a cortical bone, that is located outside of the bone. If you see, that means the outer periphery it is called as the cortical one, and whereas a spongy kind of a structure which is there, that is called it as the cancellous one. So the strength approach, so most of the things, that means the load it will be get beared by the cortical one, whereas the cancellous bones, that is a spongy one, they are act as a damping kind of the thing, that means to absorb the shocks and to absorb the sudden impact. So these particular cancellous bones, they are that means the spongy kind of a structure they are using it. So apart from that, the other the bone compositions, it is in a micro level, it is having this particular kind of the chemical compositions which are there. So and during the bone filling processes, normally we may require to go for these particular three ways which are there. That means the autograft, allograft kind of the things which are there. So hope somebody that means you may are having a understanding regarding the what is mean by the autograft and the allograft. So basically the thing is that uh, we can use the that means from the body itself, that means the person who is having the injury, to them we can chisel out the some kind of bone components, and then crush it and again use it as the materials for the bone repair purpose if required, particularly or otherwise we can have the additional or the out that means the source from the outside that can be used, and these are the two ways by which we can do the bone substitutes or the bone remodeling can be done. Then but this is not the only, that means we can't only look the bone in a single manner. So basically it is related with the bone tissue engineering. Rather we must require to understand the concept of the bone tissue engineering. So as per the bookish definition, it is a interdisciplinary field that applies the principles of the engineering and the life science towards the development of the biological substitute that restore, maintain, and improve the tissue function. So basically, all these aspects, when we require to study any kind of a biocomposite, we should not that means look it in a isolation that biocomposite it is only developed. We must require to have go ahead with the tissue, because ultimately when we require to prepare any kind of a structure, referred it as a scaffold, that structure need to have a compatibility to grow the tissue, because ultimately the originality or the patient specific nature we must require to inbuild. So that particular entire study we must require to include it or require to be done, referred it as a tissue engineering. Here also, when we do any kind of the scaffold structure, so then we are required to have that means a we must require to grow the tissue, and once the tissue it is grown, then only we can able to say that okay, so that particular scaffold or that particular substitute, it is a, you can call it as a applicable one. Otherwise development of the anything and claiming it, it is not refer it as a scaffold one, unless otherwise it is been uh, uh, develop the appetite, or you can call it as a layer of the tissue onto it. That means the tissue growth and the function, it whatever the original function it is there, that it has to restore. Not only the tissue growth, it cannot be seen it is the hard tissue only. That means सिर्फ बोन के टिश्यू नहीं, उसके अंदर के सॉफ्ट टिश्यू भी जो है, दैट मीन्स दैट ऑल्सो वी मस्ट रिक्वायर टू look it into that. And for that purpose, the one of the important parameter apart from the strength, the porosity, it is also important, because through these pores only the we can able to that means pass the fluid or the whatever the ingredient it is there, that is the that it can be done. So here the bone scaffold, it is a porous structure. That means that means the entire, you can call it as the study it is to be done. That means development of a porous structure. That means the another one, it is the cell seeding, and then whatever the location which is there. So there the in that means the it has to be appropriately substituted to restore the function along with the functions of the tissue. So these are the things which we must require to consider while development of the tissue. That means not necessarily only the tissue strength to be the composite strength to be investigated. Apart from that, there are several factors when we require to go for the design, that is the porosity, the pore size it is there, then the strength, then the biocompatibility, biodegradability, as well as the manufacturing aspects also to be understood. Then these are the technical terms, that is the osteo-inductive, osteoconductive, osteo-integrations. So these are the prerequisite, that means it has to meet this particular attributes to whatever the tissue which we are proposing. So then obviously the step, the stability process and the technique which are there, so that also we must require to go ahead. That means there are n number of techniques from which we can able to synthesize this particular one. So one of the technique which we have adopted, that we will discuss it here. So that means here we have noted down, because in the different patents which we have highlighted, so there we are using the different kinds of the technique. That means the solvent casting, particulate leaching kind of a technique we have adopted it for the fish scale. Then gas foaming kind of a technique, here we are use it for the bone, that is the waste bone kind of a things. So like that the techniques are there, so that we can able to use it for the synthesis of the bone structure or bone materials. So chemically, if you require to see the details of the hydroxyapatite, so it will be look like this, and there can be the different kinds of the sources through which we can able to prepare this particular uh, hydroxyapatite, or it can be used it. So first, that this is a very interesting, and not necessarily for the scaffold purpose. Here this particular powder which is there, no doubt still when we do the survey, still the China, it is a very that means a leading market or captured the markets of the hydroxyapatite. Whatever the implants which that is the dental implants which we have prepared, or the structure which we have prepared, they all, most of them are brought it from the China. But the source material, it is a hydroxyapatite, so we can able to prepare the dental implant once the powder it is ready. And as all we are aware that we can use it the 3D printing technique for development of the dental implant. Similarly, for the orthopedic implants, again, the if we are having the appropriate formation of the hydroxyapatite compatible to the bone, and the appropriate binder it is available, then we can able to go for the orthopedic implant by using the 3D printing technique. Then we can even go for the bone filler kind of the thing. That means whenever the cracks it is there, that is the then we can able to substitute, or we can use it the hydroxyapatite material as a filler materials to heal the gap, as well as we can able to stimulate give the stimuli for the tissue growth also. Then again, the this hydroxyapatite being derived, if it is derived from the natural, you can call it as the sources, then that particular hydroxyapatite can be used it as a use for the drug delivery thing. That means particularly a tablet can be prepared, that is the base composition, it is prepared from the hydroxyapatite, being it is a rich in the calcium and the phosphate. Then it can be that means and it can be dip it into the solutions where let us consider the paracetamol tablet if it is to be prepared. So then for the paracetamol tablet, we can have this particular base material, and on that the chemical coating it can be given, and it can be use it as the that means for the drug rider also, that particular it can be used. So even we can able to go for the paste kind of the things. It can be use it for the various kinds of the antiseptic creams can be also prepared from this, as well as again this is a scaffold which it is already discussed it. So the basically the motivation behind doing all these particular things, it is the majorly the road accident which we are having, uh, not only in India but across the globe. Then second one, it is that because of the war or the casualty which is happens because of the confrontation with the enemy, or whatever you can call it as. So in that also the injury, particularly in the military sector, the injury it is happens. So and they require to recover fast. So for that purpose, this particular study it can be plays a very important roles. So that is the basically you can call it as a motivation. Apart from that, small incidences which are there, that in the you can call it as in the house also some incidents happen. So in that also this particular uh, material it will be a useful one. So in all here the sources can be for development of the hydroxyapatite. There can be two sources. One can be a natural source. Here you can from the pink side which is there. So all these are the natural sources, whereas there are the artificial sources are also there. So that, or you can call it as a chemical combination, or chemical can be used to prepare the hydroxyapatite, and that is referred it as the synthetic one, and it is called it as the naturally derived one. So this particular hydroxyapatite, it has whatever the which we are going to develop, it has to pass this particular test, that is referred it as the XRD test, same tape, same TGA, bioactivity, and so on and so forth. So all these tests it has to pass to uh, say that it is a hydroxyapatite. For the based upon that we can identify what are the chemical composition, what is the functional group which is there, what is the crystallinity which is there. Likewise, so all that particular informations which we require to have from this particular one, and once this particular information it is obtained, so then these are the things which we exclusively require to do it for the bone scaffold, or to develop a composite for the bone scaffold purposes. So these are the things which one can being just within a line I will tell that. So what is the purpose of this particularly FTIR? Basically it is to identify what are the functional groups which are available in this particular. So for that purpose the FTIR technique it is used. The XRD which is basically determine the phase composition of the material and the crystallinity which is present it here. Because all these things in details it will come in the latter course. Similarly for the ACM, that is the surface morphology, for judgment of the, or to quantify the surface morphology, for that purpose this same technique it is used. Then likewise the different kinds of the technique, that is same EDX techniques, it is also a very much useful techniques for chemical element present in the materials, to identify the different chemical the presence in the material for that purpose. Then the TAME image it gives us the internal microstructures that it can be identified at the atomic scale. So for that purpose the that is the TAME test it is performed. Then thermogravimetric analysis. So whether the material which we have developed, it is thermally stable or not. For that purpose, the TGA it is done. Then because whatever the material which we have prepared, it has to be that means tested for the bioactivity test. So whether the developed material it is a bioactive or not, that means on that particular material the cell seeding can be possible or not, or normally it is referred it as the appetite forming ability. So that we are required to do it in the outside, that's why it is referred it as in vitro. So that means not directly done it in the patient. So first it has to be investigated outside. So for that purpose, the simulated body fluid, it is to be prepared, and it is nothing but it is a artificial, uh, you can call it as a fluid which is prepared outside, and it is claiming to be equivalent to the blood plasma containing of the all the constituents which is available into the blood plasma, kept it outside, and then the test it has to be prepared. So for that purpose, then we can require to also degradation test, because whatever the material which is there, because it has to face the environment and for that during that process the degradation it is also then that is also we required. Then cytotoxicity test.
Sir,
Hello.
hello. One of the participant is asking, can this process be adopted for bone marrow problem?
So okay, so definitely it will be adopted for the bone marrow problems, but from our side we have not gone into that details. Okay, so that means the bone marrow testing and other thing we have not done. We are only looking up to the scaffold formation, and we can say that the tissue culture which is happening on the scaffold. We are not dealing or not yet investigated or any research pertaining to the bone marrow kind of the things. So uh, I cannot that means give a expert opinion onto it, but it can be extended. What I personally feel after doing so much of research in this particular one. So these are the, you can call it as the test which we require to do it for quantification of the to call it as a scaffold one. So not necessarily some structure it is to be built and refer it as a substitute to the bone. All these particular things we must require to investigate. So these are the machines which are there. So just I will show the pictures which are there. That is the FTIR, XRD, particularly in our institutes. So these are there. Some of the tests we are doing it outside. That means at the IITs and different organization we are sharing the materials, particularly for the cell seeding purposes. We are having a tie-up with the AIMS Bhopal. There we are that means sending our materials whether the cells it is been seeded or not. Similarly, we are also having a tie-up with Datta Meghe College, which is very near to that is located in the Wardha. So we are also having a tie-up in with that with this particular organization. Along with that, the Silchar Medical College it is also there. So that means in a collaborative manner we are doing the test. That's why some you can say that the papers which are there, so it is also having the affiliations of the IIT Guwahati and other that means the institutes also. So these are in details the things which are we are that means doing the testing. That means the various kinds of the testing which we are doing it. So now here onward, we are only focusing it on one of the particular method which I am want that audience to be understood, and for that purpose I will just ask my research scholar. He will take over the things for 15-20 minutes, and later on we can have a discussion, just an overview, because if suppose the slide number, if you see that it reaches to the 150, so but in a rapid form only a overview it will be given, with a little bit idea that what the things which we have done in this particular one. So just now I will hand it the discussions to my research scholar. Just I will introduce him. His name is Mr. Amdadul, and he is a research scholar, and his research topic, it is not that means he is not only restricting to the whatever the things which is presented here. So he is going beyond one step ahead. That also I will just tell you that he, no doubt, he is preparing the scaffold, that is the base component, that is the hydroxyapatite. But apart from that, we are synthesizing the graphene oxide from the coconut shell. As all you know that the coconut shell, that means नारळाचा वरचा भाग जो आहे तो normally that shell, it is thrown outside. So that particular coconut shell, which we are using it for generating the graphene oxide and the reduced graphene oxide, and this reduced graphene oxide and graphene oxide, it will be incorporated or included it into the scaffold, and this particular structure, it will be subjected to the electrical pulses, so that the acceleration in the tissue growth, it can be monitored, because this particular, after inclusion of the graphene oxide into the hydroxyapatite, we believe that the conductivity of the material, it will be increased, and this conductivity factor, it can be also linked to the tissue growth, and we obviously those person who is having the pains or having a problem, particularly the bone defects, it is there, if it is been rectified by this particular means, the tissue growth, which is otherwise required normally 6 to 8 weeks time span, it can that is the routine where you can apply the plaster and other things, okay. But where the plaster and other thing, it is not possible to, then there we must require to go with this particular kind of the technology, that means the implant can be that means the thought, or we can require to have a substitute of the bone materials to be employed. So for that particular, for such a critical cases, we require to go for that means we can require to have the tissue growth to be accelerated, so that the relief towards the patients can be given. So now I just ask my scholar to present it, and within 20 minutes then we will stop, and later on a discussions can be done.
Thank you, sir, for giving me the opportunity. Good evening to all. So as Sarah discussed in detail about the different material and that is used for different application, that is discussed in detail, what are the different materials and its application, different characterizations that need to be done, basically focused on bone tissue engineering application. So now I will just discuss the different objective, that is synthesis of this material and its different physicochemical, mechanical, biological characterization, basically focusing on bone tissue engineering application. So coming to the first objective, which is to synthesize hydroxyapatite using wet chemical precipitation technique. So wet chemical precipitation technique basically is where the chemical is dissolved in the solvent and mixed it to obtain the precipitate. So here the flow chart for the synthesis of hydroxyapatite as shown. So initially, where the hydroxyapatite is prepared using calcium chloride and disodium hydrogen phosphate, where both the solutions are prepared individually by maintaining the ratio of 1.67. Then sodium hydroxide solution also prepared of 1 molar. Then both calcium chloride and disodium hydrogen phosphate solution is mixed properly, and then sodium hydroxide solution is poured into the solution to maintain the pH. Then it is stirred 40 degrees Celsius for 24 hours at pH 10. Then after mixing it for 24 hours, it is filtered using filter paper and washed using distilled water to obtain the precipitate. Then it is dried in oven for 48 hours at 70 degrees Celsius. Then to to observe the effect of sintering temperature, the samples are sintered at a different temperature, which is at 900, 1000, 1100, 1200 degree. And after sintering, it is ground using mortar and pestle to obtain the fine powder. So after synthesis procedure, it is observed that the yield is obtained at 900 degree, maximum yield is obtained at 900 degrees Celsius, which is obvious because of low temperature, means compared to other. Then coming to the characterization part, which is first one is Raman spectroscopy to obtain the dependent Raman shift, basically to observe what type of powder is prepared. So it is observed that for the temperature at sintering temperature at 900,000 and 1100, B type of hydroxyapatite is prepared, and at 1200 some of the peaks are not observed, which basically confirms B type of beta tricalcium phosphate. Basically, B type of hydroxyapatite is suitable for bond tissue engineering. Then coming to the XRD part, basically to observe the phase identification and the crystallinity of the prepared sample. And it is observed that the prepared sample are well crystalline in nature, as the sharp peaks are observed. And from the table, it is observed that the samples prepared by sintering temperature 1000 degree, the crystalline size is maximum as well as the crystallinity, which is 95.5. Then relative density and shrinkage test also performed. Then from the above analysis, it can be concluded that B type of hydroxyapatite is prepared at a temperature range of 900 to 1100 degrees Celsius. Beyond that, there is formation of a beta tricalcium phosphate. Then from the XRD analysis, crystalline nanohydroxyapatite is prepared. Based upon the analysis, it can be observed that at sintering temperature 1000 degree, it is found to be comparatively better physicochemical properties, and which is used for the next analysis for the characterization. Then after this observation, we considered the hydroxyapatite which is prepared at sintering temperature 1000 degree. Then it is observed by preparing it by maintaining the different pH, which is at 7, 10, and 12. Then different characterization is performed. From the FTR analysis, different functional groups are observed, and it is observed that at pH 10, the functional groups are more accurate comparatively at pH 7 and 12. Then from the XRD analysis, this more crystalline samples are observed, which at pH 10, the crystallite size and crystallinity is observed to be higher. Then from the same analysis, basically to observe the morphology of the prepared sample, it is observed that at pH 10, it is plate-like hydroxyapatite particle, where the calcium phosphate ratio is 1.61, which is almost similar, same to as 1.67 calcium phosphate ratio of bone tissue. Then for in case of pH 10, it is a rod-like hydroxyapatite particle, and for the pH 12, it is oven-shaped hydroxyapatite particle, and the calcium phosphate ratio is obtained 1.7. Then similarly, TAM analysis also performed. This is a particle. The particle shows the hydroxyapatite, and the particle size is obtained to be higher for at the pH 10. Then cytocompatibility test also performed, which is basically to show that the prepared material is non-toxic or not, and it is observed that the cell viability is maximum for the sample maintained at pH 10, which is 87.9 plus minus 45%, which shows the material is cytocompatible. And then again, in vitro biodegradability and dissolution test also performed, basically to observe the weight loss of the prepared sample, where the sample is immersed in the simulated body fluid for 28 days, and it shows that maximum weight loss is 5.9 plus minus 0.21%. Then in vitro bioactivity test is performed, whether appetite is formed or not. Here shows that needle-shaped structure is observed with the calcium phosphate ratio of 1.62. From the analysis, it can be observed that at 100 degrees Celsius sintering temperature and pH of 10, it yields pure crystalline hydroxyapatite with biocompatible and biodegradable property, and which is considered for the further testing. Then after preparing the hydroxyapatite sample, then it is the next step is to prepare the composite scaffold, and for preparation of composite scaffold, the binder is required. So here green microalgae is considered as binder, and the composite scaffold is prepared using solvent casting technique. Here solvent casting technique basically is the samples are dispersed in solvent, and it is poured in silicon rubber mold to obtain the different shapes for the characterization and other purposes. This is the basically the flow chart for the synthesis preparation of scaffold, where the first part is similar to the synthesis of hydroxyapatite itself. Just green algae solution is added to the solution, and after sintering it 24 hours at 1000 rpm and maintaining the pH 10, this composite viscous composite slurry is obtained, and it is filled in silicon rubber mold. After that, it is dried for 48 hours at 70 degrees Celsius, and then it is sintered in furnace for 4 hours at 100 degrees Celsius to obtain the composite scaffold, where 3 different samples are prepared by maintaining the ratio of hydroxyapatite and binder, which is 1:2, 2:1, and 1:1. After the preparing the samples, the different characterizations are performed, which is FDR to obtain the functional groups. And for the green algae, it is observed that the presence of organic matter, which is protein and carbohydrate. And for pure hydroxyapatite, this is calcium phosphate and OH functional groups are observed. And in case of scaffold, only hydroxyapatite is observed with no other traces. This basically shows the stability of hydroxyapatite in the composite scaffold. Then XRD test is performed to observe the different phases, and it is observed that in compared to pure hydroxyapatite, the intensity is less compared to the hydroxyapatite. Basically, due to it gets little bit amorphous as compared to pure hydroxyapatite. But for all the cases, the more crystalline samples are prepared, where the crystallite size and crystallinity is observed to be higher for the sample 3, which is 35.9 nanometer and crystallinity of 93.7 almost percentage. Then same analysis also performed to show the morphology. Then mechanical property, which is compressive strength and porosity, which is important. And for the sample 3, it is observed to be higher for compressive strength, hardness, and porosity. Then the TGA analysis is performed, which is basically to observe the thermal stability, where the sample to observe that it shows the residual mass is higher for the sample 2. Then in case of TAM analysis, particle size is observed, which is 70.25 plus minus 32.7. Then XRF analysis is observed to check the different elements, where shows the calcium phosphate is at the main primary element. The other trace elements are also observed. So in vitro compatibility test also observed, where it shows the cell viability maximum is 97.4 plus minus 3.2% on 4th day, which shows the good cyto compatible. Then in vitro bioactivity test is performed to check the apatite is formed or not. Where it shows the calcium phosphate ratio of 1.52. From the analysis, it can be concluded that this sample 3 shows the better result compared to the other samples. So from the above analysis, it can be seen that although it is best suitable for bone tissue engineering application, but there are some limitations, which is less porosity and compressive strength compared to the commercial bone scaffold. To overcome this limitation, next step is observed, which is the preparation of bone scaffold using the hydroxyapatite and polymer binder, which is PMMA, using modified gas forming process. Here, modified gas forming process is basically the materials are dispersed in solvent, and the porogen is used where from the porogen is used for the preparation of the samples, where carbon dioxide is released, and porous structure is to get the porous structure of the composite scaffold. And this is basically the flow chart for the preparation of the samples, which is also discussed earlier. And here it can be seen that from the same analysis, it can be seen that this is there is a porous structure of, and there is also from the elemental analysis, it can be seen that calcium phosphate ratio of 1.7, 1.69, and 1.66 for the different samples. Here, this compressive.
Sir, hello.
Yes, sir.
One of the question is Dr. Pratibha Nikam.
Okay.
How the crystallinity affects the role of HA in scaffold? That's how.
How the crystallinity affects the role of HA.
In chat box, she has written.
Okay, I'm just checking.
So, she can also speak. Madam, you can unmute yourself and you can talk as well.
Okay, shall I complete the slide, or I will?
Okay, no problem, no problem, sir. No problem.
Okay, I will discuss it later after completing the slide. Is it okay, sir? Okay. This after this hydroxyapatite PMA composite scaffold is prepared, And then this is from the same analysis, porous structure is prepared. Then in the mechanical, from the mechanical testing, the compressive strength is observed higher for the sample at H hydroxyapatite, which is maintained the ratio hydroxyapatite PMA maybe 70:30 ratio, which is observed to be higher. From the above analysis, it is observed that the sample prepared at 70 to 30 ratio, the better results are observed. Then the results are also observed for the maintaining the ratio of porogen is to hydroxyapatite, which is 1:1 and 2:1. And from the analysis, almost similar results are observed. However, at a ratio porogen ratio hydroxyapatite is to porogen 1:1, it shows the better result. Then similarly, in vitro bioactivity and cytocompatibility tests also performed. So from the analysis, overall analysis, the use of a synthetic binder and the modified gas forming process enhances the mechanical property and porosity of the scaffold. However, there is a poor biological property from the above analysis it is observed. To overcome these limitations, the hydroxyapatite is prepared using galine, caprine, and bovine bonds. Different types of bonds are used for the synthesis of hydroxyapatite. This is basically the flow chart for the synthesis of hydroxyapatite from the galine bond waste, where the bonds are collected and pre-treatment is also performed, which is different chemicals. HCl and sodium hydroxide are also used for the pre-treatment purposes. And different tests are also performed, which is FDR, XRD, and the functional groups and these peak positions are also observed. And from this analysis, this porous network of collagen fibers are observed from this analysis, where the same shows the hydroxyapatite particles. And from the EDX analysis, it shows that this calcium phosphate ratio is almost 1.67. There is TM analysis performed for the particle analysis, which is 0.61 plus minus 2.81 micrometer. Some of the conclusions are drawn. That is, then similarly, the hydroxyapatite is prepared using caprine bond, and these different characterizations are performed. It's the same analysis. So then next is hydroxyapatite also extracted from bovine bone, and the different characterizations are performed. Then after the synthesis of hydroxyapatite from the different sources, the composite scaffold is prepared using the polymer PLG and PMMA using modified gas forming technique. So this is the flow chart for the preparation of the developed scaffold, where the synthesis process is almost similar to the discussed previously, and then different characterizations also performed. This is FTR, XRD, SAM, EDX, and it shows that this porous structure. However, from the above analysis, it is observed that the mechanical strength is poor compared to the synthetic hydroxyapatite and PMMA. Then for this, the composite scaffold is prepared using a PMMA. Then these characterizations, all the characterizations are performed, and then it is observed that the caprine-borne derived hydroxyapatite scaffold displays better chemical, mechanical, biological result compared to the galine and bovine-borne derived hydroxyapatite scaffold. However, the degradation and cytocompatibility is poor. Then for this for this limitation, this zinc oxide nanoparticle is used for the preparation of a composite scaffold along with bovine-borne derived hydroxyapatite and PMMA, where zinc oxide nanoparticle is added to the composite, and then different characterizations are performed. And finally, the comparative study is performed for all the analysis.
थोड़ा सा बता दो प्रोटीन एब्जॉर्प्शन पीछे वाला.
So from the overall analysis, there are some conclusions are performed from the different objectives. And the summary of the analysis is that for the different composite scaffold, the compressive strength, porosity, degradation, and cell viability are compared. Then the ratings are given. Different ratings are provided for this particular characterization, and from the overall analysis it can be concluded that hydroxyapatite that is synthesized from the caprine bone, and by incorporating the hydroxyapatite in the composite scaffold, that is in PMMA and zinc oxide, the total score is highest. So it is best result from the above analysis. Thank you.
What are the questions?
Hello, sir. So from the this there is one is question how the crystallinity affects the hydroxyapatite in a scaffold. So basically for the composite scaffold, the crystalline material is best suited for this composite scaffold. But as observed in hydroxyapatite, there are more sharp peaks are observed in the XRD analysis, which is crystalline structure. This also impacts in a different for different temperature. At very higher temperature, that is at above, as observed from the analysis, which is at above 1200, some of the peaks are observed, which is related to the beta tricalcium phosphate. But for this composite scaffold of in the application of bone tissue engineering, the highly crystalline material basically best suited for this application.
I think this was the question asked by Pratibha Nikam ma'am. Ma'am.
Yes, sir.
Just now, sir answered the question.
Sir, still I have not satisfied 100%, but just I would like to repeat that particular question in that particular manner. You have synthesized all this material with the best crystallinity. You have confirmed that with the XRD, but still, what exactly rather we should go with that particular amorphous HA or not at last?
Basically, when it is incorporated with a binder or with different material, it gets slightly amorphous in nature. But overall, the best crystallinity is suitable for bone tissue engineering.
But how, sir? We are dealing with the porous nature also. Meanwhile, there are different combinations with your materials, isn't it? You have shown that particular very nice porosity of the material.
Yes.
And still we are going with that particular crystallinity also.
Means crystallinity is from our analysis what we have observed, we got the more crystalline, which as discussed. So if we get the best crystalline material which is best suited for bone tissue engineering application, obviously we will use that material, ma'am.
Thank you, Saji. There is another one question, means just I just go logically with the things. You have that particular made HA from the Caprin, isn't it? Last one, that 19 point something, the best result with the last, means that tabular form, isn't it? You've
Yes.
shown that particular thing.
Yes.
So rather, I'm just means taking the conclusion of that particular things. The somewhat means the peoples who are non-vegetarian, they can absorb that material naturally.
Okay.
By taking that particular diet, isn't it? We can
Yes.
conclude that particular thing in that way. Means, is there any relevance? Who is going with that particular non-vegetarian diet, they can absorb that particular type of caprin or HA with that particular diet. Is it possible?
Possible means I am not exactly aware. Means I have not got in depth in this matter, but it is not consumed. It is implanted. So I think it can be used for that purpose also. But I will go through it properly also for this purpose.
Thank you, Saji.
Okay. Thank you.
Hello, sir.
Yes. Sir.
Have you performed any drug delivery testing on your?
No, not yet. We are currently for this analysis, we are mainly focused on bone tissue engineering application basically. For this for biological analysis, biocompatible test and cytotoxicity test, these are performed. So other are not yet explored. So,
Okay, sir. Thank you.
thank you.
Hello.
Yes, sir.
Sir, you told that you have incorporated some nanomaterials in the matrix, isn't it?
Yes.
So,
Yes.
can you please tell me what will be the effect of aggregation, if any, on the mechanical properties, and tell me the remedy also for that.
Here we have incorporated zinc oxide as a nanoparticle, where it is observed that this compressive strength and hardness we observed, which is means incorporated with natural hydroxyapatite, as discussed earlier, as we have discussed the different composition. So from this above analysis, it can be observed that for this caprin bone hydroxyapatite that is, and incorporation with a zinc oxide, we get the higher mechanical strength, which is compressive strength, also hardness.
Can you give me any evidence?
Means as we have performed here, this test is performed, and results are also shown, sir.
Sir, have you checked the aggregation? Because when we are incorporating nanomaterial, there might be aggregation, na? And that will affect the properties.
Sir, same analysis is performed to check the morphology, sir. So it is it shows this oval shaped particle, this it is observed, and as we know the calcium phosphate ratio for this natural bone is 1.67, and it is here also this from the analysis, elemental analysis, it shows that it is almost 1.67. That is for the different sample, it is varies from almost 1.55 to 1.7. So
How they are affecting mechanical properties? Is there
so,
any kind of once again the same physics and chemistry behind it?
Sir, from the analysis, as we have incorporated, means added porogen, so we will getting the porous structure. The more will be porous, means there will be better for the analysis, and their porosity also affect the compressive strength. If we get the less porous, then the compressive strength will be higher, and vice versa.
Mhm. And what is the reason of that porosity?
The porosity basically depends on the means for if we incorporate a different composition for the samples, then the porosity may vary. Means for let's say if we hydroxyapatite and the binder is means maintain the ratio is 70:30 or 60:40, and then their porogen also incorporated at a ratio of with hydroxyapatite at 1:1 and 1:2. So the porosity that also varies.
Mhm. Is there any other reason?
For this one, that mainly the
Because what I'm trying to ask you is aggregation may affect the properties, isn't it?
yes, sir.
Aggregation is very important.
Yes, sir.
You might done the scanning electron microscopy,
Yes, sir.
from which you get that mechanical strength is good. But what is the actual reason? What is the physics? What is the chemistry behind it?
Sir, as the means here we have used a different composition. So as the hydroxyapatite is crystalline in nature, so incorporation with the binder, it may not get that much crystalline as compared to the pure hydroxyapatite. So as also porogen is also added, so we'll get the porous structure. So there may be for this analysis we will get the different morphology, slightly different morphology.
Okay.
Mhm.
Okay, sir.
Okay, sir.
Okay, sir.
Already we are 7:30 now. Pratibha ma'am, you still
Sir,
have
last
some
question,
question?
please.
Okay.
Yes, sir. Actually, regarding graphene
Please
oxides
be
morphology.
specific, ma'am, because the second speaker he has also joined, and it's 7. Okay, please ask.
Yes, sir. What type of morphology of graphene oxide will be best, means suitable for that particular application? Just this is the last question, and thank you for giving me the chance.
For graphene oxide and reduced graphene oxide, and it is some irregular shape also observed, but means we can synthesize the graphene oxide and reduce graphene oxide like a single layer or few layer structure. So for the bond tissue engineering specifically, a few layer graphene oxide is best suited for bond tissue engineering applications, and it may also vary on the different synthesis method also. That is a modified hammer method also used, a chemical CBD also used.
Shall we conclude?
Thank you, sir. Thank you very much.
Thank you, sir.
Okay. Since we are running out of time, and the resource person for second session has also joined, I think we should stop here.
Okay, sir. Thank you.
So I am thankful, Dr. Ashish Deoghare sir, and especially you as well.
Yes. So
I'm thankful, Dr. Deoghare sir, for
Actually,
joining this faculty development program. I know you are traveling. I mean,
no, I am not traveling.
no, you have
Tomorrow,
you
tomorrow I am having a plan.
tomorrow you have a plan, but still you were as per telephonic conversation, you are busy with some your work, and in spite of that,
Actually, at our institute, we are having the inter-NIT tournament also.
okay.
And here we are also having one program given by the Ministry of Education, Bal Vaigyanik.
Acha.
So that means for the kids, we have to explore that whether they are having the inclination towards become a scientist or not. So for
Okay.
that, so many programs are going on. So
Yeah.
that's why I have taken the aid. Definitely, the scholars are doing the work. Faculty
Okay.
members, they are only representing it in a
Uh-huh.
best possible manner. So thank you for giving us an opportunity and bearing with us. I hope some of the patent from your institute or the persons who are there, so they can also yield from this particular side.
Okay. I think since we had a very good interaction with participants, so based on that, I can say that it was a very good session. Also, there are few comments from the other participants as well. So, on behalf of college and ASM International, I thank you for joining the session, and thank you. Namaskar.
Okay, so
Okay.
uh,
Okay, sir.
today now I have to again go to the internet VNIT faculty members reach here. So
Okay.
I have to, that means I have to talk with them. Okay.
Okay, sir.
Okay. Thank you.
Thank you.
Thank you,
Sir.
Ashish
Thank you
sir.
very much.
Thank
Thank
you.
you, sir.